Now after that, just to go for derivation of association. As you know, in case of association, particles are reduced, so molar mass going to increase. That mass is abnormal molar mass. So let 1 mole of substance undergo association to form associated molecule. Let alpha is the, what is that alpha? Once again, degree of association. See, moles associated, it is the division alpha by n. Moles left in solution 1 minus alpha. So what is the I? Bent off factor. I is actually total number of particles formed after association divided by 1. 1 minus alpha plus alpha by n divided by 1. So I into 1 is equal to 1 minus alpha plus alpha by n. That's why I minus 1 equal to minus alpha plus alpha by n. Take common. I minus 1 is equal to alpha minus 1 plus 1 by n. Or see, I minus 1 is equal to alpha 1 by n minus 1. Since we have to take alpha, so this is the I minus 1 upon 1 by n minus 1. 1 by n is, what is that? Molecule associated. For example, benzoic acid undergo dimerization. Take 2 molecules of the benzoic acid in benzene, undergo dimerization to form C6H5 COOH. This is the 2. That means it is associated up to 1 by 2. It is the dimerization. It is due to formation of, hydrogen bond. So the way you can calculate association, right now, see, or this association is due to the formation of, like if I say benzoic acid, it is 1 mole of benzoic acid, see the other mole of benzoic acid. What the bond is formed? Dotted line representing, yes, hydrogen bonding. So there, due to hydrogen bond, molecules are associated. Like acetic acid, they also in benzene or in organic solvent are associated, undergo dimerization. That means, but if acetic acid in water, then they are dissociated because water acts as electrolytes. So at that time there is no association. Acetic acid, whenever placed in water, it undergoes dissociation. Dear students, here for example P4 undergo association to form 1 by 4. This is called tetramerization. Sulfur 8, it is known as octamerization. It is 1 by 8, like this. So the way you can calculate the numerical based on, you see, association. Let us discuss a numerical here based on, you can see the association here. Dear students, I just put you a question here. Is it clear to you? Association and dissociation? Okay. Now write down the numerical and solve it. The question is, 10 gram of ethanoic acid is dissolved in, write down, is dissolved in 200 gram of benzene. Ethanoic acid is taken as 10 gram in 200 gram of benzene. This is the solvent. 200 gram of benzene. Calculate elevation in boiling point, that is delta TB, if 80% of ethanoic acid of the ethanoic acid forms dimer in solution, what is that? Solution, right? So, dear students, we have already taken Kb for benzene data given. Kb for benzene equal to, this is already given in the numerical, that is the 1.62 Kelvin kg mole inverse. This is given. So what we have to calculate? 10 gram of this dissolving 200 gram of benzene, calculate elevation in boiling point. Delta TB is equal to Kb into Wb upon Mb into 1000 upon Wa to be multiplied by Van Hoff factor. Because of all the qualitative properties are associated with Van Hoff factor I, either relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, or even in osmotic pressure, I must be multiplied, because molecules either undergo dissociation or association. If molecule neither undergo dissociation, association, I become 1. Urea, glucose, lactose, they always remain 1. But NaCl, I is 2. K2SO4, I is 3. Like acetic acid, I 1 by 2. Benzoic acid in benzene, I 1 by 2. Because they undergo association. That is why, what you have to calculate? Delta V. Kb is how much here? This is what Kb for benzene is 1.62. Given mass of solute 10 multiplied by 1000 upon molar mass of ethanoic acid is how much here? 60 into given mass of solvent is here how much here? But we don't have the I. What is to be I here? How can you calculate I? See, since it is the association, so alpha is equal to I minus 1 upon 1 by n minus 1. Can you tell me how much alpha? 80%. So you can take 0.8 equal to I minus 1. Since it is the benzoic acid or ethanoic acid undergo association like this, so it is the 1 by 2 minus 1. Because of you take acetic acid, undergo dimerization to form CH3, COOH2. That means 1 by 2. CH3 COOH, it is what? So I is equal to 1 by 2 here and 0.8. That means once you will solve this, you will get the I, that you need the I here, and then I will be getting here I is equal to 0.6. So delta TB is equal to 1.62 into 10 into 1000 into 0.6, 60 into 200. The way you can calculate, that is the elevation in boiling point. Most probably you will get the answer 1.25 Kelvin. Is it clear to everyone? The way you can calculate association. Before that I will explain you dissociation. Dear students, one numerical from your textbook, that is from exercise examples. Further I solve another numerical. What is that? Write down everyone. Numerical is, listen, this is the another question is, from the examples here, examples 2.12 textbook question, right? 2 gram of benzoic acid, 2 gram of benzoic acid is dissolving 25 gram of benzene. Shows a depression in freezing point. Shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant. Molar depression constant. You know what is this? This is also called as cryoscopic constant. For benzene is 4.9 Kelvin kg mole inverse, right? Find the percentage association. Find percentage association if benzoic acid undergo dimerization in solution. So dear students, tell me if such kind of question may come in your paper based on the association, what you do first? First you find the parameters. Solute amount is given here, 2 gram of this, and then dissolving 25 gram of benzene. It is the solvent. 25 gram is the solvent. So the depression in freezing point, delta TF 1.62. Molar depression constant, you know, cryoscopic constant. When 1 mole solute in 1 kg of solvent, what was the values? This one. Find percentage association if benzoic acid undergo dimerization. So the formula you can apply here, delta TF is equal to KF into WB upon NB into 1000 WA. Again we have to take Van Hoff factor, right? I is the, you know everybody, Van Hoff factor. So all the parameters we have given, and then what you have to calculate, this, so the depression freezing point for benzene is this one. Find percentage association if benzoic acid undergo dimerization. So tell me, what is delta TF? 1.62. What is KF? Very nice, 4.92. Given mass of solute 2. Multiply by 1000. We don't have I. See here. So this is the MB of the benzoic acid. Molar mass of the benzoic acid 122. You remember it? And given mass of the solvent is how much here? 25. Right. So the way here you have to, I is equal to 0.504, or I can say, I can take I equal to, that is approximately 1/2. Once you will solve all these parameters, you will get here I. Question is to calculate percentage association. That means you have to calculate alpha. So tell me anybody, what is the formula for degree of association? Alpha is equal to I minus 1 upon 1 by n minus 1. So alpha is equal to, what is the I here? Vector factor, how much I have calculated? 0.504, approximately you can take 1 by 2 minus 1 upon, since benzoic acid undergo diagonalization, so always you take 1 by 2 minus 1. I hope approximately you get 1, since question demanding percentage, what? Association. Therefore 1 into 100, 100% is associated. So I hope that I have made it very clear that this kind of question you will try to solve, and if you have any problem, kindly discuss. Right now, as you know, practice makes a man perfect. Go for the numerical from your textbook, and this is all about dear students solution. So go through every unit, keeping in mind the board examination, see the previous year paper, and try to analyze and introspect yourself, how much your assessment and what is your level of preparation. Right? It's all right. Next class I will discuss electrochemistry. Thank you very much.